All right, so we are now on chapter 8 still. So we're still in chapter 8, and we're now moving on to section C, which is going to be called gradient. Now, you will hear me refer to this as slopes. I will try my best to always use gradients, since that's what your textbook is using. But I've always learned it and taught it with the American books as slopes. It's the same thing, just using different words, but just because it's what I've always done, it may just naturally come out. I'll try my best to keep using gradient instead, since that's what your book has. But your objectives for today is going to be to understand a gradient or a slope. So you want to know what a gradient or a slope is. Remember, they're the same thing. So whether I say gradient or slope, just know that it represents the same. But we want to understand what it is. And then we want to know how to find the gradient or the slope of a line when given a graph or when I'm giving you 2 points. All right, there's a formula that you'll have to learn for this one. Same thing as just with the other one. I'll write the formula on the board, but you'll also get some fake formulas that you'll have to be able to identify which one's real and which one's not. All right, well, what is a gradient or a slope? Well, a gradient of a line measures its steepness. So it's telling us how quickly our slope, it's telling us how quickly our line is changing. So it's measuring its steepness. It's saying how quickly is it rising or how quickly is it falling, or is it not falling that much at all? So if you look here, this graph, it's increasing pretty quickly as we look at it. It's from this point all the way to here, it's graphed, it's changed very rapidly. So that means it has a high steepness. As compared to this graph here, if we look at this green one, it's increasing in the same direction, or both going in a positive direction as we go to the right, but clearly the yellow line is increasing quicker than the green line is. And the same thing here, if I look at this line, this pink one, it's decreasing as we're moving from left to right, and it's decreasing a lot quicker than the other line, the blue one I'm about to highlight here is, right? So one of the things that we can just tell her that the gradient or the slope tells us, it tells us the steepness of the line, or it tells us how quickly it's changing either positively or negatively. There are slopes of lines that have no slope, zero slope, and then there's slopes of lines that have an undefined slope, and we'll talk about those in detail in just a few minutes. But what the gradient or the slope tells us is it tells us how quickly a line is increasing or decreasing. All right, and one of the things that you're going to have to know is when we talk about the steepness, we always compare the vertical change. So there's our vertical change, the black line, over or horizontal change, which is our red line. So we always compare it as vertical change over horizontal change. Right? And then since we always compare it as vertical change over horizontal change, we know that according to our y-axis, our y values compare our vertical change, or that's our y values tells us how we're increasing or decreasing vertically. So it's going to be our change in y. And then we know that according to our x-axis, that's going horizontally. So that means our x values tell us how we change horizontally. So you'll hear me say it as change in y over change in x. You won't really ever hear me say vertical change over horizontal change. You'll hear me say change in y over change in x. And you should know that they translate to be the same because our y-axis tells us how we're moving up and down our coordinate plane versus our x-axis, which is telling us how we're moving left or right in our coordinate plane. And one of the things that's kind of important for you to do before you ever tell me the slope is you can identify if it's going to be a positive or negative slope when just looking at the line. So I'm going to draw 4 lines here, and we'll talk about how we can just tell or determine what their slope is just looking at it. All right, and I'll tell you how one of the ways, a video I saw before, how to explain it to our students, and it is a little interesting. So you read it just like a book, as an English book. So you would read it left to right. So we look at our graph and we look at the leftmost point that we see, and we look and we say, all right, as we move from left to right, is this graph going above it or below it? And remember, as we move up on our y values, it is positive, and as we move down on our y values, it is negative. So that means if this graph, as we're going left to right, is going up, that means it's going to have a positive slope, right? And if we look at our leftmost point of our graph and it's going down, it's going downwards, that means it's going to have a negative slope. If we look here at our leftmost part of our graph, it's not going above it or below it. So that tells us that there is no slope, or the way that you will represent this mathematically is it has a slope of 0. And if we look here, there is no leftmost part of our graph. Our graph here is just going up and down. It's not moving anywhere left or right. So we would say that this slope is undefined, and we'll talk about that more detail in a minute. But one of the ways I saw a video is they said draw a person on the leftmost part of your graph and act like they're walking. If they're walking uphill, then that means they're moving in a positive slope. If they're walking downhill, then that means they're moving in a negative slope. If they're walking where they're not going up or down at all, and it's a horizontal line, then that means that there is a zero slope. And here, the only place that the person can go is on top. And if they try to walk, then they will splat down at the bottom and their body will be left undefined. That's one of the videos I saw, and sometimes it works to help people remember, help kids remember the different slopes that we have when just looking at them. Right? So it's important to be able to identify what our slopes will be before we solve it, because it can help you know if you made any mistakes anywhere. All right, so now there's a few questions that we're going to go through and just solve, and then we'll be done with this video. I think there's 4 in total. All right, so for this one here, remember, first thing you should do is say, is this going to be positive or negative? Well, I see as I'm going from my furthest left point, I'm reading it like a book, I see that my graph is going up, so I know that the slope is going to be positive. Right now, the way that you solve these when you're just given a graph and not any points is you must look and see, well, where all these little boxes, we look and see where does our graph cross the corner of the box, right? That's the most important part. It's not where does it cross here, because we need it to be exactly in the corner. Right? And I'll explain that in class why it needs to be exactly in the corner. But I see here it crosses the corner right there. I find the next one that crosses here. Remember, I told you it's change in y over change in x. So we count and we see how many spaces did our graph change going up in y to get from one point to the other. So it's 1, 2, 3. So I see it's going up 3, so I can write 3. And it's over top of change in x. So it's going to be going 1, 2 to the right. Right? So that means we changed y 3 values to get from one of our points to the next. We changed our x 2 values. The variable that we use to represent slope or gradient is going to be m. So we would say m is equal to 3 over 2. We said it was positive to begin with. Our number is positive 3 over 2. So we know that at least we didn't make a mistake with the signs. Here we see we have a horizontal line. Remember, if my guy is walking on our line and he's not going up or down, or our line doesn't change at all, it is just a zero slope. So I know my slope is equal to 0. Right? And one of the ways you can see this mathematically, if we were to do the same thing, well, here it crosses our corner, and here it crosses our corner again. Our y value doesn't change. It doesn't go up or down at all, so our y change in y remained to 0. And when we look here, our x value then changed 1 to the right. Well, 0 divided by anything is equal to 0. So we can know right away that our slope is just going to be equal to 0. Right? We pick our leftmost point just to be able to identify what our graph is going to be, just looking at it. Is it positive or negative? I see my line is going down as I read it from left to right, so I know it's going to be negative. Right, now let's go ahead and find the actual slope. So I picked a point. Here it crosses in the corner, and here it crosses in the corner. So I need to ask myself, how does this slope change? So it goes down 1. So since we're going down, we know that means it's going in a negative direction. So I know my change in y is minus 1. And then I look and see, well, how's it changing going to the right? 1, 2, 3. So my change in x is 3. So it's negative 1 over 3. Right? Remember, we talked about this one, a vertical line. And if we draw the person on top and he goes to take a step, his body is going to be undefined. So we know that this slope right away is going to be undefined. Now, the reason why it works mathematically is we pick 2 points where it crosses the corner of a box. Let's just say here and here. All right, so our change in y, we look, okay, it's going and it's changing 2 in direction up, so it's changing positive 2. Well, it's not going anywhere left or right, so it means our x isn't changing, so the change in x is 0. And we know that anything divided by 0 is undefined, so that's why we say our slope is undefined. All right, let's move on and solving an equation when I'm giving you just a point, or solving a slope when I'm giving you a point. All right, sometimes you will just be given a point, and here I'm saying that we have a point 1, 3, and q, or p is 1, 3, and q is 4, negative 2. Right, just like we were solving with distance or midpoint, the first thing we have to do with this is we have to label our points x1, y1, and x2, y2. Just like with distance and just like with midpoint, it doesn't matter which one you label, it's going to give us the same answer regardless. All right, but now the formula for slope, it is equal to y2 minus y1 divided by x2 minus x1. Right, so by doing y2 minus y1, it's telling us how we're changing from one point to the other. So it's telling us our change in y. Same thing with this. When we're doing x2 minus x1, it's telling us how we're changing with our x value, so it's the change in x. After we go ahead and denote which one's x1, y1, we simply just plug it into the formula. So m is equal to our y2 minus 2 minus our y1, which is 3. So it's y2 minus 3, or I'm sorry, negative 2 minus 3. And then our x2 is 4, our x1 is 1, so it's 4 minus 1. And then we just solve. Well, negative 2 minus 3 is going to give me negative 5, and 4 minus 1 is 3. So my slope, or my gradient, between points P and Q is negative 5 over 3. Right? So you would write m is equal to negative 5 over 3. Right, so here it says the graph alongside shows the distance traveled by a car over time. So if we look, this is the starting point. So when we're starting, if we're talking about a car traveling distance over time, well, our x-axis represents time. Well, when we just start, no time has passed, so we know it's 0 for x. And when we just pass, no distance, or when we just started, no distance has passed either. So this black point here has a point of 0, 0. Then this point has 8, I'm going to write this a little bit bigger, has 8 and 600. So that's telling us that after 8 hours, we traveled 600 kilometers. So it's asking us to find the gradient of the line. It doesn't matter which one you label. So I'm just going to say that this is x1, y1, and this is x2, y2. It doesn't matter which one you do, though. They're interchangeable. So remember, our slope is equal to y2 minus y1. Make sure you have this written down over x2 minus x1. And now we just plug in and solve. So my slope is equal to y2, which I said was 600, minus my y1, which is 0, and x2, which I said was 8, minus my x1, which I said is 0. So our slope is equal to 600 over 8. Now we've reduced this as much as we can. So I know that 600 divided by 8 is equal to 75. So I would say that my slope is equal to 75. Right? So that is the answer for A. Find the gradient or the slope of the line. There's my answer for A. For B, interpret the gradient found. So remember, it's telling us how quickly we're changing. It's telling us our change in y, which in this case is distance, over our change in time, which in this case is hours. So it's telling us our kilometers, that's our change in y, so we're representing our y in, over our change in x, which is represented by hours. So it's telling us how quickly we moved on average through this time. So it's telling us that we drove approximately 75 kilometers per hour. Not approximately, we drove 75 kilometers per hour in this distance, in this 8 hours time travel, all right? And in the future, when you learn calculus, you can actually, because we know that it's impossible. We don't drive in a straight line like this. When you're driving a car, you increase your speed, you come to a stop at a red light or a stop sign, and your speed's constantly changing. So in calculus, we can actually say when you're traveling, what speed you're traveling after 2 hours on that particular point, and what was your average in those in that time. But until you learn calculus, we can only look at it as a linear path. So we would say that this car drove 75 kilometers for every single hour. All right. It's not saying that that's the speed that they necessarily drove the entire trip, that from the beginning they just zoomed right off to 75 kilometers an hour and never slowed down. It's just over the entire trip. On average, they were traveling 75 kilometers per hour. All right, and then the last thing, I was going to go through this example here, but I'm going to wait for this in class. All right, so we're going to open up and start this in class because I want to make sure that everyone knows how to plot the point 2, 1. And in case people don't know how to plot the point 2, 1, I just need to make sure that you do. I'm not sure if we talked about this in class before. I can't really remember, so I just want to make sure that you do understand how to plot the point before we go ahead and do this. So we will start off in class with this question. All right, so that is it for this video.